In this video, our goal is to take information such as a vertex in a point or a couple of x-intercepts in a point and find a quadratic model that would fit those points. Very similar to when we've taken 2 points previously and found the equation of a line. Now we're going to be finding the equation of a quadratic equation. Today in this video we're going to be using vertex form and intercept form because, again, depending on your given information, they're fairly easy forms to use. If you're given the vertex, it'd be very simple to plug into vertex form in for h and k the information that you already have. So we can say that y equals a, remember the stretch or shrink that we don't know yet, times x minus h. Now h is the x coordinate, remember, of your vertex. So we can say plus 1 for this model, squared plus k. And remember that k is the y coordinate of your vertex. So we can plug in 4. Now, in order to figure out what a is, what that stretch, whether it be a stretch or a shrink vertically, is, we need to take that extra random point, similar to, again, when we try to find a y-intercept in y equals mx plus b form, we always plug in a point for x and y. So let's go ahead and take out x and y, and let's plug in what we know. X being 1 means that y should end up being 8 for our given model. Then all we have to do is find what that a value is. So 8 would be equal to a times 1 plus 1 is 2, squared is 4, plus 4. Let's go ahead and subtract our 4 over to the other side, and finally divide by 4, and it just so happens that for this model, a comes out equal to 1. So our model would be y equals 1, which we don't need to write in there, times the quantity x plus 1 squared plus 4. And that model should go through this point with a vertex at negative 1, 4. If you had x-intercepts, the same idea holds, only now we want to use intercept form, because obviously we can't plug those in for h and k in vertex form. They're not the vertex. But if we say again y equals a, our stretch, times x minus our first x-intercept, so plus 6, minus the negative 6, times another quantity, x minus 7, our other x-intercept given, now we're off and running. If we erase our y and our couple of x's, and again take the one extra random point that we're given, because we need that one extra piece of information, we plug in our 80 and plug in 2 for both of the x's, then we can go ahead and do some algebra and figure out what that a value is. 2 minus 7 being negative 5. So negative 80 equals negative 40a, and a equals 2. So our model this time would be y equals 2 times x plus 6, x minus 7. And in intercept form, we now have a model that should run through that point to negative 80, but have x-intercepts at negative 6 and 7. Remember that you could always FOIL that together and distribute your 2, or over here in vertex form, you could always FOIL out x plus 1 squared and add in your 4 and get them into standard form, or else play around with them in various other ways and figure out how to convert them back and forth using other algebra skills. Now, why would we ever want to use this? Well, what if we were an engineer and we needed to map out or model the shape of an object on a computer, or just figure out the function for that edge of a model? Well, given that we've got this lampshade, we've got a picture of it in 2 dimensions, we want to model that curve of the lampshade. So we know that if we place the corner at 0, 0, that it's exactly 5 units wide, whether that be feet or inches or whatever it may be. And we also know that another point on our curve, as we look at our grid, is the point 3, 3.8. Since we know the x-intercepts, we can use intercept form. So let's go ahead and write that out. X minus p, x minus q. But because we also know that our intercepts are 0 and 5, let's go ahead and take out p and q, and we'll plug in 0 and 5. At that same time, we know a random point, so we can take out our y coordinates and our x coordinates, and we can plug in the point 3.8 for y when x was 3. And again, the only piece we're still missing is a. So 3.8 equals a times 3 times negative 2. 3.8 equals negative 6a a equals 3.8 divided by negative 6. So let's go ahead and pop that in here. 3.8 divided by negative 6. Press enter, and we get negative 0.633 repeating. So negative 0.63 repeating here. And if we want to write out our model then, y would be equal to negative 0.63 repeating. And I'm okay with that, by the way, because a negative a value means our parabola opens down, which is exactly what our picture looks like. X, and actually we don't even need to say minus 0, so let's go ahead and just take out that set of parentheses there. But the second set of parentheses is x minus 5. And we have a good model then of our figure. I hope that helps you finding vertex form and intercept form. In another video, we'll describe how to actually go find standard form given any 3 random points. Good luck and have fun.